Coming back once again, students, we learn about the ladder friction, problem solving on ladder friction. A uniform ladder of 4 meter long, weighs 200 Newton. It is placed against a wall, making an angle of 60 degree with the floor as shown in the figure. You can see 60 degree here. The coefficient of friction between the wall and the ladder, between this is the wall, okay, and the ladder here, the coefficient of wall with the ladder is mu w. I can take it as 0.25, whereas between the between the ground and the ladder, I can call it as mu g as equal to 0.35. The ladder is, in addition to on its weight, has a supporting man of 1000 Newton at the top of the ladder. A man is standing at this point B. Calculate two entities are there. To the horizontal force P to be applied to the ladder at the ground level to prevent slipping. So it is about to slip. So how it may slip if it's a ladder, how it may slip? Definitely the ladder will move down and it will move on the floor in this direction. So to prevent the slip, I should apply P in this direction. Got it? How to analyze? When the ladder is slipping, the ladder will move down the wall along the length of the wall, correct? And when it is moving, the ladder will move in the left direction. The ladder will move in the left direction. So the prevention P force has to be applied in the direction towards the ladder. That is the first question. Second question is, if the force P is not applied, what should be the minimum inclination of the ladder with the horizontal so that it does not slip with the man at the top? Now, in the second case, he is telling if this P force is not there and you should incline, which is not at 60 degree in the second case, you should incline the ladder in such an angle theta, wherein it will not slip down. It can hold the man at the top point B of weight 1000 Newton. Okay. Now there are two quantities to follow here. Okay, I'll take a new sheet. Right. First thing is first unknown to find the value of P. The value of P. What is the free body diagram? Free body diagram of the ladder we have to draw at first. Whenever students you draw the free body diagram, that will tell you that you know the problem exactly. You are analyzing the problem correctly. Okay, I'll draw the free body diagram. This is the way the ladder is placed. So very easy here. This is the ladder which has been inclined, right? And you find this is a ladder being placed at an angle of 60 degree, correct? Fine. And you find a person standing here of 1000 Newton, correct? 1000 Newton. And the weight of the ladder is 200 Newton. It acts exactly in the center, 200 Newton. And the distance from point A, I call it as and point B, 200 meter, right? Now, we have to define the friction direction, right? Friction direction has to be indicated. So, we'll indicate in this way. The motion of the ladder will be down the wall, right? The motion of the ladder along the length of the wall, it will be down. So at this point, let me call this point as A and this point as B, whatever it is. Now when it is moving, this ladder is slipping down, the friction will be opposite direction. So I call it as FW. At this point, you find NW. right? Normal reaction W. What is W? W is representing with respect to wall. Why the friction is W in this direction? Because opposite to the motion. How the motion of the ladder is taking place? Down the wall, right? There is one more friction developed here. So the ladder is going to slip in this direction. The motion will be in this direction. Okay, when it slips, you can try at home. Just you keep the ladder, how it is slip, it will move in the left direction. So the friction will be in the opposite direction. I call it as F floor or F ground G, and the perpendicular normal reaction as NG. And keep in mind, students, they are asked what is the value of P. P is the additional force. P is the additional force. Okay, how to go about? I'll try to do it here only so that I get space to write the diagram equations. First, I'll take sigma. Same thing, sigma h is equal to 0. Okay, write positive and negative. Fine. Then I find plus P. Okay, plus Fg. Then minus Nw. Any of the horizontal forces equals to 0. We have the values of Fg and G values are being given in the problem. In the problem it is given. It's all the same. No. Between the wall and the ladder it is, that is mu W is equal to 0.25 and mu G is equal to 0.35. Okay, we should keep that in mind. So plus P Fg, I can write it as mu G is equal to Fg by Ng. Okay, so mu G is how much? How much mu G? Mu G is 0.35. So 0.35 into Ng minus Nw is equal to 0. Okay, so I call this as equation 1. Similarly, I go with sigma V is equal to 0. Positive up, negative down. Okay. What are the forces I find? Come in the order plus Ng minus 200 minus 1000 plus Fw equals to 0. Ng value, I have the Ng value. What is the Ng value? No, I don't have the Ng value. Very sorry there. Ng value is not there. Minus 1200, I can write it as Fw, I can write it as mu W is equal to Fw by Nw. So Fw is mu W into Nw equals to 0. I have the value of mu W. How much? So mu W value is 0.25. 0.25. So Ng is equal to Ng minus 1200 plus 0.25 of Nw is equal to 0. I call this as equation 2. Now, there are so many unknowns. I have to go with one more equation. What could be the other equation to solve? I have to take the last equation of equilibrium, that is taking the moment at the particular point, right? And equating to 0. I'll take the last equation of equilibrium as sigma m is equal to 0. So clockwise positive, anti-clockwise negative. Here you can take preferably at any point, either at A or B. Which point you would like to choose? At either places you find 3 points meeting, 3 forces are meeting at either points, or A and B, at the floor or the wall. So I can definitely go with the, I'll go with this point. Let me call it as A, point A and point B. I'll go with the taking the moment about point A. So point A, I'll take the moment about point A. So I'll take the forces. So moment of all the forces, point A is here. Fg will be equal to 0 passing to the same point. Ng is equal to 0 passing to. P is equal to 0. Then you have 200. How it is moving about point A clockwise. What is the perpendicular distance for this? This is the perpendicular distance. Perpendicular distance will be, it is cos theta, right? Cos 60 is equal to adjacent by hypotenuse. So it will be 2 cos 60. Then I have 1000. What is the moment it is making? It is making a clockwise movement. 1000 into what is the perpendicular distance? 4 cos 60, right? Cos theta adjacent by opposite. This is a side I want, right? Next, FW, how it is making the moment? Moment it is making as a moment of anti-clockwise. So minus FW. What is the perpendicular distance? This is the perpendicular distance. Again, it will be 4 cos 60. Next, coming to NW. NW, how the moment is taken up? Moment is taken up as anti-clockwise. So what is the perpendicular distance? Here the perpendicular distance is this. So it will be 4 sine 60 for the triangle. Okay. So I'll be writing here. That would be okay. Fine. So I'll indicate the same here. Okay, I'll take a little more space. I'll clear this. Anyhow, we have the equation. Underneath, one more equation is there. Okay, I'll take the moment about point A. So clockwise 200. I'll write here sigma A is equal to 0. 200 into it will be 2 cos 60, right? Then is that clockwise? Yes, clockwise. Plus 1000 into 4 cos 60, correct? Plus, minus FW. FW will be equal to 4 cos 60, okay? And minus NW 4 sine 60, okay? Or when you solve all that, so 200 2 cos 60 plus 1000 into, you solve it, you get the answer cos 60. Here I can write it as mu W into NW. 4 cos 60 minus NW 4 sine 60. So upon solving, you get the value of NW. NW as 554.98. So once you get the value, upon substituting back into the equation, you get the value of P as equal to 183.54. Okay, students, I'll end the session now. Thank you all.